drug metabolism, and then respiration. Respiration was the last topic, the most fundamental process. I feel awkward. This, when these guys go missing, I ask myself, कोई कसर छोड़ी क्या? उनको तंग करने में इतना तो भाग गए चलो. So that's what I feel. I really pained them a lot, so they left. So, well, where are my people? Muthu, Sampath, அந்த காலையில அட்டெண்டன்ஸ் எடுத்திருக்கோம்ல, பார்க்கலாம், உங்களை பிடிச்சிக்கலாம். We will see who are the guys missing. Yeah, but I think we are quite happy in the sense that there will always be some fallouts and jettisonings. Yeah, it's okay. So now we go to a complex system wherein until now what we did was matter interacting with what? Matter. Correct. Now the primary thing is matter interacting with some kind of radiation, right? Energy radiation. So now I am a tadan as usual. ये गलत जगह पे साउंड इफेक्ट दिया. एक और बार इफेक्ट किया टाइम. So लात मत देना. So basically, when biologists, do you like to deal with radiation and light and all that? Do you like that? Why? If you mostly, visual thinkers, basically biologists are visual thinkers, and they don't like to deal with these kinds of things. Although we might use spectrophotometers and all these things on a routine basis to understand radiation's interactions with matter is very complicated. Why? Because at the core of all the matter interaction is also quantum chemistry, but this is more direct. You have to know things. So honestly, I am not a big physicist or big quantum chemist or anything like that, but I am what? Bull-headed. Right? So, do you see horns here? Unicorn. It's coming out like this, no? So, yeah. Basically, I found this problems in the explanations for photosynthesis. And there was a wonderful one person, I forgot his name, I forgot his name. It was a long time back, 2017, that I was doing this research. After that, when I solve a particular level of problem, after that I lose interest. For me, the problem is what interests me. If problem is solved, I don't ultimately, after a particular point, okay, it's done, you don't feel like it. So this person, when I was trying to do research, he was in almost, he was undergoing cancer therapy. He was a BE from, or BA long back. He had an engineering degree from MIT. And serious cancer problems. And he wanted to keep his brain involved in life. He wanted to have something to make himself work on a regular basis. So he was an electrical engineer and he started studying photosynthesis. So some of the things that he has written there, you should go and if you have the time, try to find out. So the point is that I'm saying that when biologists do things that require more abstract thought, more theoretical foundations, they go more on, until now you have seen, now this matter radiation interaction, when it comes to interpreting them, they go, until now it was crazy, now it's going to go super crazy, it's going to go. So let's start the photosynthesis session. Now you saw CPO was like, P450 CPO, P450 respiration, very similar. All right. Now, this photosynthetic system is also very similar to the respiratory system. Can you say, just let us interact a bit, what are the things? We'll come here. There is already things put up also. So how many of you studied some plant biochemistry? Good. So yeah, good. So do you know some common terminology? I have only 15-16 slides, so I thought I'll consolidate what I learned earlier, and we'll go slowly in this session. I don't want to complicate this session. You got a lot of crazy chemistry things in this, but I thought I'll keep it simple and straight, so that you will see that any complex problem can be approached by simple, ideas and questions. So, have you heard of the Emerson experiment? Anybody? No. Yes, you have. Good. So, have you heard of Z-scheme at least? How many of you have heard of Z-scheme? All right. Good. How many of you have heard of Koch-Jolio cycle? Besson-Koch? Yeah, you have. Good. So, so they're all wrong. So, all those things are wrong. Hey, I wanted to show you something. Can I, Prabhakar, ஒரு வீடியோ போட்டுடலாமா? ஒரு சின்ன ஒரு வீடியோ வாங்க. What photosynthesis folks did, you will see what they do. Come. Yes, that's fun. You will like it. It's fun, real fun. It's a video. YouTubeல இங்கே எடுக்கலாமா? Wonderful. அங்கேயா? இதுல போலாமா? Okay, இது அப்படியே போட்டலாம்ல? This one. How many of you want to sing for a casual thing later in the evening or something? It's like, no, basically you volunteer the other person, right? Really? You can sing. Yeah, you can sing. We'll unwind a bit later after his presentation is over in the visual. If you okay, starting. Yeah. So I don't want you to perform. I want you to be successful. But you please listen to reason, way of presenting, the way of writing. If you constantly attack, you are attacking yourself by doing that. Given the today, something that knowledge is movement of presentation to scientific objects, the last 4 years, this is very knowledge. Now there is one knowledge. But this is not a story. It is an art. Where I'm sorry, everybody knows it. Now it's over until 4 years back. So only showing I put that. Because you keep on saying that there is this work is controversial. The last week I said it is controversial. Why is it controversial? Because you. What I'm telling you. Because you don't know how to present it. You don't know how to write it. You don't know how to do it. You have to use simple. I even read your answer. 10 words are there. So you want those people to know some English, they're bombastic English, they'll understand. Not a simple-minded thing so that the common man publishes in nature. And your work is that it should be published there. But you are not working in that end, you are working opposite. You are killing yourself
how you can present your thought, how you can write your paper, so that people will understand your view. I'm sorry, as I said, take my PhD, take my doctorate away. Because I mean that. I know you can say that. I'm saying that. I mean well for you. And I believe in you. That's why I wanted you to be here. But you disappointed me by not explaining your theory from the step one. I have never ever said that in my life to anyone.
I think it's a matter of usually no question. That is coming to you because that's what
as I said, I thought for 40 years and I've listened to speeches after speeches and talk after talk since 1956. Well, two Hindus who came to I know, and the kind of magical meeting not part of this place. I've given you the paper. No, that's another thing. That is again very wrong for you. I've given the paper, not I mean you read every word and you should understand. No, you should be able to write in a way that people understand. I'm here. Don't explain because this is a problem. And it continues to be a problem. So unless you learn that you have a brilliant idea and you want to learn to sit down, to write it in a way that people will understand step by step. Mind you, that your words, even when you're talking around you, what do you say? This is not the way to speak to a group of young people. You need to learn. And if you don't learn,
Listen to this.
Yeah, you are very arrogant. Yes. That arrogance is the highest level. No, I'm only interested in your life, only interested. I believe in you. Everybody says, Govind, are you crazy? You're going to listen to Govind? No. Because I thought I'd come here and you just
once everything is perfect.
Yes. Did you hear what he said? Are you crazy? You're going to Murali's talk. Right? Why? They know if they come to my talk, they'll have such problems. They cannot stand. They cannot reason. I did not say. That is a 1.5 hour long video. You will see. He called me aggressive. Why do you think I took off my beard and all that? Look like a guy without feathers. I like my hair. So I have come so that I become non-aggressive looking, as effeminate as I can be. I like my hair. These guys and all guys say, "Sir, take off your beard. It gives an aggressive look." Well, that's not the thing. You see the video. This is a 1.5 hour video. I am as lame and as docile as lamb personified. The dove. I don't believe in violence, aggressive, and all that. Guy doesn't allow me to talk. Tries to systematically sabotage my talk. Then I said certain things. You can go and see the video. I said, I like him. Okay. Let me tell you, I like him. But this is not the way science is done. Now, when you want a person to give a talk, you listen to that person first, right? He was not allowing me to talk. I said, "Chalo bhai, ab aapne jo keh diya, haan." Then after a particular point, I said, enough is enough. Give it back to him. So I just said, "So tell me, Govindji, what do you think about your Z scheme?" Because I was talking about respiration. He's a textbook author, big guy in photosynthesis. So he got upset then. And I said, "It's very simple." I kept on saying the word, "It's very simple. It's very simple. Anybody can understand this. It's very simple." That was. If you can irritate me, I can irritate. Yes, it was my strategy. He pissed me off and I gave him back. And then I know, I can control myself. But then there's a saying, you know, you stand idle for a moment, nobody really cares. So why was he so flustered? All his lifetime's work goes away in seconds. Nobody likes that. I went to IIT Bombay in March. It was the first place where I conducted a workshop. 2 days workshop. 2 days, 3 days, I don't know, 2 days. The whole of bioscience and bioengineering boycotted. This place has 80 research scholars in chemistry and physics. 2 are here. What about the master students? Chemistry and physics? Nobody. I had advertised. Nobody comes. I went and announced, and it was invited. I was royally snubbed at IIT Bombay in their department. Nobody came around. 3 people in the talk. I wrote to the NPTEL, tomorrow we'll have a talk on bacterial motility, right? The person who was conducting that, I got 3-4 professor friends of mine to write to him, meet me, talk to me. No, they won't. And he thought he can come and, no. I kept quiet because he was a senior professor from UIUC, where Lowell, my Guruji, he's my alma mater. He's an Indian. I have a lot of respect. But then he, thought that he can do that. No, I said it's very simple. It is very simple. Understand that. It is very simple. Nothing is sophisticated. All this quantum physics and all that. Simple ideas. That's how nature works. All right? That's what the whole thing was about. If you are interested, see that video. This is only the end part. No, it is there on YouTube. Satyam Jetu, my channel. My channel is Satyam Jetu. It is there. My daughter, she is an artist. She draws something and she puts on the what is that called? No, something else. Yeah, Instagram. Yes, she puts on Instagram. Within hours, she gets 20,000 likes, 30,000 likes within hours. I do the most earth-shattering work. 40 views after 6 months. Kya baat hai. Wow. Anyway, so sometimes you like it. I'm not envious that my daughter gets following. But then I'm worried about humanity. That our people, they don't really care. If you don't care, nothing happens. So I have my life to live too. So this is the channel. Yeah, who was showing that? Yeah. Yeah, wonderful. He is showing that. So these are the video that is where the konja keela varingla. See how I used to be. This dhoti kurta. That's how I was. From my 30 age, I went to IIT Madras and they rejected my candidature because I was in dhoti kurta. Tomorrow I will come in dhoti kurta. Right? Yeah. Yeah. Oh, it is there. So I've been at it for quite long. So this is my 3 days. My boys are here. We have come a long way. Now I think it really doesn't matter to me anymore. If you people don't want it, if you don't want, you go and go to study. If your professor comes and says the nonsense again, and if you are able to take it, you should say, what? How can protons be pumped? You tell me. You ask your doctor, do you know what oxygen does in your body? How does liver metabolize the liver, all the drugs that you give us? If they are not able to say something that is convincing you, screw your degree, you should say on their face. That's how it has to be challenged. Because for me, I have approached these people. They will not change. They are not going to change. I believe that I have worked for it. I believe that it should benefit the younger generation that's coming up. They have lived that. They are just holding on to their vain prestige. It's not a question of, it is not a question of, All those people who say, oh, science takes its jolly time, acceptance, recognition. I don't care for acceptance, recognition. No, I do not that way. A couple of novels will not hurt anybody. So, but then the point is, why should our younger generations be taught things that we know is wrong? That I do not like. That I do not like. So that's why I start off with that particular thing that he has discouraged me. Scientific philosophy is again negation. It is not affirmation. Affirmation is politics. मैं झंडा लेके चल रहा हूं, मेरे पीछे पीछे आओ, salami ठोको. No, 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 no. We say this is not right. This doesn't appeal because we build on what we know, right? That's how science goes. When somebody says, yes, now let's have, wonderful. So let's go to the full screen, Prabhakar. Wonderful, Prabhakar. Yeah. So this is the famous thing on which photosynthesis, the most important reaction on this planet. Yes or no? Yes, sir. Food and oxygen. Food and oxygen. Both depend on this. So yours truly is the guy who is telling you how it happens. All right. I don't know how all that, but all these people have worked and generated wonderful data. Govindji and his colleagues and all those. I salute them. I thank them. But then I also rebuke them, right? Admonish them, because that's how it is. That's how it is. Karnorka adipilum avam, they say in Malayalam. But I don't believe so. Age is not a license for Tonyasam. That is, young or old, you don't do nonsense. You have to be constructive. You can be pardoned, but a scientist needs to have moral integrity repeatedly. This is political messaging. It has to be moral integrity and intellectual acuity. Two things. What it hurts is, it's simple, right? It hurts. So this is the famed Emerson experiment. This is the Z scheme. So what is actually Emerson experiment? Now they found out there are two photosystems. Photosystem 1 and 2. All of you have studied this. Now photosystem 2 works at 680 nanometer. Photosystem 1 at 700 nanometer. So what they did is, they charged at 680 nanometer. Where is that? So when the system was stimulated, exposed to 600 nanometer, 680 nanometer, you get some yield of oxygen like this. When you excite at 700, you get some. This is there in all YouTube, videos. And after my criticism, things started going away. All the wrong things, outrageously wrong things started going away. But still some of these images are still on there. What will happen is, they will not recognize my works, this murburn and all that. They'll slowly morph their ideas over a gradual period of time. Remember this. This is what is going to happen. Yeah, that's going to happen. Guaranteed. Guaranteed. How many Nobels are going to go down the drain? Do you know that? They will not do it. The whole establishment, the whole pivot of human administration, Western, whole aura that they live in, it's going to go. How many Nobels? You have seen already. So what is right and what is wrong to the mass, it won't. They'll come, but it will come in so many years. Namo nishan nahi rahega. But then this is just something that you can get for the kick's sake. You can also do some good research. So, but when both photosystem 1 and 2 were as excited with both the wavelengths combined, they found that the yield of oxygen was much higher than these two added up. Make sense? All right. So what they did is that they put it in a series scheme. That is, 680 nanometers electrons are excited and they go to 700 nanometer system, and then you get NADP formation. That is, now you have an electron transport chain. Same concept as in mitochondria. Only difference is this is chloroplast. Alright. Both are lipid stacks. Alright. So here you have a large amount of chlorophylls, carotenoids and all that here, and you have two sacs hanging for no reason whatsoever, like that complex 3, no? They were also hanging, they didn't know what it was. I have no problem that they didn't know what it was, but then it is a natural curiosity, isn't it? Some has some large protein coming out. What does it do? All right, so basically the photosystem 2's manganese center is here. Here is reaction center, all that. And as usual, like in mitochondria, coenzyme Q, here is only plastoquinone. All right, some different name, something like that. In the mitochondria, it was cytochrome BC complex or complex 3. Here it is B6F. All right, and there it was plastocyanins. Here, taking here. Here it is plastocyanin. What was it there? Yes, cytochrome C. So one relay agent in membrane, one relay agent in soluble phase, and then you have ultimately making NADPH. And once again proton pump again, okay, that same thing. All right, that orchestration of beautiful things going on, that music, all that is, please realize that is put there so that everything soothes out. That effect is that way. It cannot go like that, the molecules. So here is the Koch-Jolio effect cycle. Koch-Jolio cycle is, they say that water stays wedded here. What was the thing that stays wedded in oxygen, right? Same theory, long term, two molecules of water stay wedded to make one molecule of oxygen. So how many electrons are there? 4 electron reactions, right? So here, for making one molecule of NADPH, how many steps have to go? Electron transfer? Almost 100. If you see the total count of electron transfer processes, that many steps have to go. And here, that means that when light strikes at the reaction center here, the manganese complex should release electrons in a very beautiful tung, 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 like that, cyclic manner. One photon hits here, it gives tuck. Another photon hits, this goes tuck. No, but the only problem is the structure and all got was aware much later. The Koch-Jolio cycle was proposed earlier. This thing, manganese center is away from the reaction center, right? So that part and all will come back later. So, and the ATP synthesis is through same Paul Boyer system. So they found that there's a periodicity for dark acclimatized chloroplast to release oxygen, and that's what the reason for this one. So these 4 ideas, 1, 2, 3, 4. These are the 4 ideas, somewhat like the same respiratory system, exactly same. Only thing is here, energy for reaction is provided by sunlight to make NADPH and ATP. There, oxygen to water. Here, water to, no, wrong. There is no water to, no.
Wait, I forgot the question.
Yeah, my question was phrased wrong. So here, the electrons was in respiration, electrons moved from what to what? Correct. NADH to? No. NADH to? NADH2, oxygen to make water. Here the electrons are coming from water to make NADPH, NADH or NADPH, and liberating oxygen from water, right? So it's anti-parallel. Yes, one goes this way, one goes that way. So that is the difference. But then the energy is provided by sunlight. Now, serial connectivity. Now you imagine, I have one point here, I have one point there. I have two pit stops. Now I want to get from here to there. Will increasing the traffic, I want more electrons to go. Yes or no? That's what the observation is, this Emerson observation, right? That is, more oxygen will be released when more NADPH will be formed. More NADPH will be formed when more electrons go. Yes? So, what is it? So now you have got, make a comparison with a pipeline connectivity. It's something each one of you can understand. And this one, I got into this because when I was in Mala, there was a girl. She asked me while I was teaching this, she asked me, don't you think this looks awkward? How can this be like this? Exactly, that's what I felt when I was studying it. Exactly. So how could that girl be having the same doubts? It's like, Rajananga, that kind of same thing. Robert Louis, Hans Christian Andersen, same thing. These people have put up something and we are all made to go there. So I didn't like that. And you see a simple analogy. You have two pipes, okay? If you want a greater flow from a reservoir, would you like to connect it in series or in parallel? Yahan se, I want more traffic to go from this point to that point. Will I have one single road or do you want multi-lane roads? That is parallel. This is one after other is series. So now these are the things that easily you can understand very clearly. So the serial connectivity logic is not right. Even if you take it to electrical systems, when you connect things in series, what will happen? You remember 12th class physics, anybody? Resistance? Yes, increases. Yes, basic idea. So, that Emerson experiment, what do you think of it now? Because of this, the yield went high, so they connected it in series to explain the enhanced yield. It cannot explain. Yeah, that is a simple logic. Couldn't you have done this? Couldn't you have called this out? Now do you understand how human civilization is? You have chosen a wrong profession, that of a scientist. If you want to succeed, you want to have followers. Things are different. Yeah. Sad, but true. That is what truth is. So, here, cyanobacterium, once again, I'm going to drill it into you. Let no teacher, let nobody come and tell you this otherwise. If you did that, lanat hai mujh pe. I spent all my time, but I knew it, no? I told you, people will not come, those will come, will not care to understand, those will care to understand. I'm a little, I've been doing this for a lot of years, but yet I'm optimistic also. Please understand this, no? So, if you calculate the protons aren't there. Even if protons are there, you cannot see cytochrome C is common in both this electron transport. Now cytochrome C is doing downstream. See, cytochrome C takes to make water in respiration and to break water in photosynthesis. Now it has got an electron from water. Now it decides, I got an electron from water. I am supposed to take it to other direction. Can it do that? No. Can it do that? It cannot. Plastoquinone, should I take it to that guy or should I take it to the other side? It cannot decide like that. So that's a fundamental thing. And also, there is, yeah, that is another point coming there. So, chemiosmosis is redundant. And the point is, I told you, since in the atomic structure, which one occupies maximum space in terms of dimension? How big is an atom? How big is an atom? Some student from there, the student who is not looking at me with you. How big is an atom? General, an atom. Any atom. You choose your atom, and she is now saying something to her. How big is an atom? I told you, elephants, can they go in a car? No, because you know from your day-to-day experience. Now, if you want to understand molecular processes, you need to be in a position to visualize how big those atoms are. What is the time scale of those reactions? So, can anybody tell me the dimension of an atom? Don't Google and tell me. That is not good. My dear boy, what are you looking at? Attendance, okay. Yes. Anybody? Atom. So hair, what is the dimension of a hair? See, when I was doing my master's, I went to molecular biophysics unit. Professor Vijayan asked me this. I was the fourth in the list, you know, of merit, because I goofed up one simple question. Nanometer to angstrom conversion or something like that. That's what gives you a feel. So my question is, how big do you think an atom is? A proton is 0.0002 angstroms. So small. Why? Because it doesn't have any electron. The electron is what gives it the volume, the size. The dimension of the nucleus is minuscule. This is something that we have studied. So, but then people don't understand. What they do is, there are oxaloacetate goes to that is what becomes biochemistry. Yes or no? That is something that you should run away from, because that kind of information, one sleep, one bath, one semester gone. You need to be understanding the significance of what you study, right? And then if you come to your house by this road or that road or that road, you can get to your house. You should feel comfortable about the subject, about the molecules that you are familiar with. So now you see, proton is too small. There cannot be things to pump it out like that. And very beautifully, the structures and distribution was found very late. So photosystem 2 is in the interior stacks predominantly. So plastoquinone should take it and jump stacks to come to photosystem cytochrome B6. So things like that, you know, it doesn't make spatial distribution sense. And then, like we said earlier, this plastocyanin topography is not conserved like it is in cytochrome C or cytochrome B5. And it is available in both stroma and grana. As per their theory, it is only in the one phase, right? So why? So then, most importantly, in 1990, which one was it? Zhang et al. 1997 or something, no? Yeah. Plastocyanin was knocked out. You know what knocking out? That you should know, bio people. Yeah. That gene for that was taken off, and that plant did not have plastocyanin. Now, as per the classical theory, plastocyanin, so here, plastocyanin is what carries from photosystem 2 to photosystem 1, and this is a serial arrangement. Now, if plastocyanin is not there, should it be a functional photosynthetic system? No. What did they do? They conveniently disregarded these developments. Have you heard of the name Daniel Arnon? Anybody? Have you heard acyclic photosynthesis? Yes, he's the guy who gave you that. When Daniel Arnon said that all that we teach is not right, you have to change it, what happened? Daniel Arnon was, we don't want you in the community. But murburn cannot be done like that. You do understand, no? Yeah. So, now the third one, chloroplast, pigments. There is something called light harvesting complexes. They said these light harvesting complexes, they tap sunlight, they make excitons, and somehow there's something happens and they jump and they reach the reaction center. Why? How? Sophisticated things only quantum physicists know. Alright. Alright. I have scant regard for such ideas. So you see, and none of the chlorophyll molecules are covalently tied. They have no real, they're randomly scattered all over. So how can it be a deterministic process? It cannot be. So yet another aspect, when a membrane is maintained at a potential difference, ions will flow in a particular direction. Yes or no? That is, yes, all of you know that. Here, protons go up, protons come down, electrons go up, electrons come down, anything can happen. It's Vellarika Pattanam, as they say in Malayalam. No rules, nothing abided by. And you see the reaction. This is the reaction that the classical theory requires for making what is the textbook advocated idea, 1464 kilojoules per mole. So 4 photons each of, as per their theory, the Z scheme is like this. See, 4 photons here, 4 photons here. That's how it goes. So you calculate 4 photons of 680 nanometer and 700 nanometer of each amount to 1387 kilojoules per mole. So it's violating laws of physics, thermodynamics. Anyway, all these are violations of laws of physics only, but this is specifically basic arithmetics. Suddenly, I put 2 rupees and I get 20 rupees just for the heck of it. And then the number of steps, they say we use Marcus equations and we try to sophisticated things. I'm not going to go into details. You can easily see too many steps of low viability. The time and the redox potential. What is the redox potential concept that you learned here? Negative to positive. That it does. So sufficient distance, electrons have to go like that. Marcus theory, and then quantum coherence and computing. For how can you do that? Now, if all that is because of sticking to this, if you can go beyond that, except murburn. Murburn is basically thermodynamically downward. But here in this theory, just one thing is upward. That is, light gives, ejects, and that's the only upward reaction. Everything else is here also down in the murburn model. It is not going up and down, seesawing like, you know, your बच्चों का जो park में होता है ना, what you have, you go up the electrons going on, you know, what is that roller coaster ride? Yeah. So that girl asked that doubt. That kind of rekindled my disbelief. Her name is Nita Unnikrishnan. Just for, you know, good people's names should be mentioned. They need not be big scientists. All these big scientists, their names will die. This kind of things, interactions, genuine curiosity, between teacher and student. That is what is the hallmark of humanity. I told you, tiger continues to hunt pretty much the same way. We don't do that. We learn from generation to generation. That's the most fundamental aspect. So how does the murburn model? Same like respiration. The other on both sides, the matrix extending proteins have ADP binding sites, and the plastoquinone and quinol are just they are absorbing electrons, things like that. So these are multiple renditions of the murburn model. See, like in an engine, you have two types of oil, one oil to burn and one oil to lubricate, right? So light harvesting complex also makes reactive oxygen species, but the charge separation is not that effective. Here they produce those raws that can immediately cater to the electron deficiencies, all right, but they are not efficient in effective charge separation, so that membrane cross membrane activities can happen. Here the basically photoactive pigments, they go, these are photosystem 1 and 2 are effective switches that do the effective charge separation. There is a reservoir of one electron species set in, and from their heat, potential difference, NADPH, oxygen, ATP, all that are formed, just like in respiration. So here is photosystem 1 and 2, they make it like that, and light harvesting complex thus primarily this, supported by NADPH dehydrogenase. So primary event, secondary event, tertiary process. Primary event is diverse pigments. What are the different pigments? Photoactive pigments, carotenoids, all that is there, all right, hemes and xanthophylls, all that. So here diverse pigments, now they have lost the electron. So ROS comes and gives those, and DRS gives those pigments their electron back. So diverse pigments are regenerated. Then membrane proteins and ROS and electrons that are coming out, they react and they give NADPH and ATP and all that. One simple reaction. It doesn't need to go through a series of hundreds of steps to make one molecule. Is it possible that evolution can make NADPH through 100 odd steps? For all that NADP needs to get is 2 electrons made. Why should it wait for that violin, all that? So this is the simple oxygen evolution mechanism. How different things can react and lead to oxygen evolution. NADPH formation is like this. ATP synthesis is through ROS. ATP synthesis come evaluation of oxygen. Simplest overall equation for a 4-electron reaction. So this was once again, we have shown in vitro oxygen superoxide can give mediate ET and other ion-centered species and all that can also. So Taiskiewicz and Roux, I think is the pronunciation, in 1987 they showed that chloroplast when presented with xanthine and xanthine oxidase, they give that. So these works were done by, once again, Abhinav. I think Abhinav, you can take that moment. I don't know whether, just say, you know, it's basically saying, you want to say? No, ठीक है, बैठ जा, आराम से बैठ जा. Okay, so this is Abhinav. So, yeah, basically, you see, these are the reaction centers and things like that. What happens is, they have large pores. All right, what happened? Okay. So once again, why should cytochrome B6F have carotenoid? Why should they have long, why are they present here? They say this is proton pump just like complex 1. But then this is, their redox potentials are crazy and they are too far. And how can the plastoquinone come? It has to come like a snake, go into the protein, come and get electron from here. It is senseless. It is continuing because people have believed this theory for long. But these theories were proposed when? When was this proposed? When the structures were not known. Yes? So that's why. So multiple low affinity ADP binding sites, pigments and Ross channels are noted on proteins. The latter is inexplicable if deterministic electronic circuit were. क्या हो गया ये आगे क्यों नहीं जा रहा है? You see how chlorophyll molecules are scattered all over. How carotenoids are scattered. Carotenoid, you know where is carotenoid found in your eyes? It is the photoactive pigment in rods and cones. Yes, correct. Carotenoid, that is called retinal. So same kind of molecules are found in chlorophyll. Sorry, chloroplast, and same thing here. So why is it not moving forward? Move agala. Move agala. Oh yeah. Okay, fine. So once again, non-promiscuity. These kinds of diverse molecules, so small to large, crazily different molecules. Photosystem 1 and 2, E donors and acceptors to photosystem 1 and 2, E acceptors from photosystem 1 and 2. How can you explain this if it was a deterministic electronic circuitry? It's a randomized thermodynamic equilibrium dictated outcome. So that is it. But partitioning matters. Which side, where it binds, that matters. So there was a huge finding, that is bicarbonate, when it is given, that also inhibits oxygen evolution. So the theory says that the photosystem 2's, that manganese complex binds to two molecules of water. How can you explain bicarbonate giving? Here, very simple. The thermodynamic equation is very simple. Bicarbonate is somewhere in between water and hydroxide ion. The ability to release that. It will give. What is so? Very simple. Our theory is not binding based. It is not specific electron circuitry based. It gives. And it explains all these beautiful things. So untenable Nobel Prizes, Marcus theory is applied, and this structure they got, but then the structure was given for the bacterial chlorophyll, which showed beautifully ordered structures in bacterial systems. But that is not what here it is. In the P450 CAM system was not what the human liver system was, right? So I told you one comparison. You take a lion, make it jump through a loop in a circus ring. In a real world, it need not. So that is not how it, so extra. Now, in spite of it's going to end now, so what is the time now? 3:43. We'll have some questions, and that's good. Your tea would come by then, and that's it. So here, you see, then why did they make all this theory? There is a very famous experiment called Jagendorf experiment. Have you heard of it? Jagendorf experiment? Nope. That's good. Good. No problem. So what he did is, took inspired by Mitchell's theory, they took chloroplast, put it in pH 4, and then transferred it to pH 8. They got ATP in dark. So he said it's a pH gradient that works to make ATP. What? Very simple. What did we say yesterday? ADP plus PI plus H. That ADP plus PI plus H plus gives ATP plus H2O. This is the thermodynamic equilibrium. Now, if you add H plus here, you will get ATP. This is very simple. It is not any, this 3-order difference of pH is not seen in physiology. Do you understand? Physiology is very different from what they demonstrated. You create something that has no relevance in physiology and show that it is what it is. That doesn't make any sense. So, and also you see the murburn equilibria, you see very clearly, so many places give forward reaction, they drive the equilibrium. See, H plus gives NADPH, right? H plus gives oxygen here. So when H plus is on the left side of the equation, available as a reactant, it puts multiple equilibriums on the right side. So what is the point of doing an experiment and showing interpretation if you don't understand the basic chemistry, basic thermodynamics that is involved? So you take my PhD away, you take my professorship away, all that comes because why? The ideas are very simple. If it was based on a sophisticated experiment that I had challenged the theories, it would be easy for people to accept. The only way that I can be recognized and all that is when people start learning what? Fundamentals. No, people say that, sir, your work should have some money-making process. I mean, come on. I know we can do that, but then that is sad. So the other experiment was Racker's experiment. This is the Racker's experiment. That is Jagendorf's experiment. This is once again what Prasad said in the morning, that you cannot use observation to reinforce your own theories in a partial way, disregarding the other important aspects. So this is very important. They had isolated complex 5 as the ATPase enzyme. So they thought that in the cell it must be ATP synthesizing enzyme. And then they had found rhodopsin. Rhodopsin is a protein that has a carotenoid in it, and it was thought to pump protons. So what they did is they constituted a vesicle, closed vesicle for pumping. All right. So here are the 4 experiments. How did Surjit show you? Surjit showed the basic steps of how a biological experiment is conducted, how positive controls, negative controls, and test reactions are made. Right. Similarly, so they had also gotten such controls. Right. What is the control here? When bacterial rhodopsin was taken alone with ADP and PI, and light was given, no ATP generated. That they say. Then ATP synthase alone with light, no ATP generated. So with rhodopsin and light and complex 5, they get ATP. Light alone with rhodopsin and this complex 5 with an uncoupling agent like nitrophenol or something like that, they do not get ATP. So this was used as a confirmation theory that complex 5 makes ATP, and that is because of H plus gradient, because the light is giving the energy here to make ATP. Now there is one major problem. This reaction of only rhodopsin gave 20% ATP compared to this, which they conveniently overlooked. Their data table is there for everyone to see. Go check the original paper. It is giving approximately 20% of this value. So 20%, how can something that does not have any ATPase activity except rhodopsin give that? That is the greatest support for murburn concept. What is rhodopsin? Rhodopsin is a photoactive protein. It has got a carotenoid. That's it. And that carotenoid, when you will see that mechanism for visual cycle, Here it makes reactive species. Reactive species attack ADP and PI, you get ATP here. That's how. It is not a proton pump. Why? The Skiff's base that is formed with the carotenoid and protein has got a pKa of 13. It cannot pump proton. It cannot.
When you say 20% ATP, what can you is the balance is energy balance. The light is coming ATP.
No, 20%. This is, suppose this experiment gave 100 molecules of ATP in a given time. This experiment gave 20 molecules of ATP. This gave 0 molecules of ATP. Light was not using, could not be used by ATPase, this complex 5.
Compared to what? The base what?
100 molecules of ATP. We are looking only at ATP synthesis. नहीं समझ में आया?
Light is the source of the energy. But source of light and source of that much ATP you should get.
नहीं. Suppose I put light to a system. I got 100 molecules of ATP in this experiment. So here I got only 20 molecules of ATP.
Energy is not fully utilized compared to.
नहीं. The yield of ATP. Unadkatji, yield of ATP. Did you get it? All of you got it? Yield of ATP. Exact number of ATP molecules. Here I got 100 molecules of ATP. Here I got. How can you control the experimentally how much exact quanta went in, how much was absorbed? All that is complex. We are just trailing the product of interest. Product of interest is what? ATP. ATP only 100 formed, here 20 was formed, but conveniently disregarded. So here uncoupling agent, they said uncoupling agent is what it does, proton pump messing up. No, it is not proton pump messing up. It is actually Ross dynamics altering. So this you will see in multiple cases. So this is the explanation for all till now, all data that is available on bioenergetics explained by Murburn concept. Not one is explained by the classical theory. So I request you, do not teach your kids Z-scheme, do not teach Q-cycle, do not teach electron transport chain, do not teach proton pumping, do not teach chemiosmosis. In fact, if you see, I'll show you that data tomorrow. After 2017, when I published my paper, you will see the number of papers in PubMed going up every year in mitochondria. The number of papers mentioning proton motive force and chemiosmosis going up every year. 2017 onwards, chemiosmosis, proton motive force going down. But I sent papers to Biochemica, Biophysica, ACTA, BBA, Bioenergetics. The editor does not take more than 2 hours. Out. Photosynthesis, within 24 hours, out. So why am I saying this? If you want to get into science and if you want to do really breakthrough type of work, be prepared. If you want to be an Apollonian is what?
So why they are not finding it logical?
They find it logical.
So why
They are not scrupulous. They are unscrupulous. No integrity.
But there should be any of the editor who should.
No, there are those who published my papers. They are here.
Yeah, exactly. For your paper only I am saying like that.
नहीं मेरे को politicize मत करो. अभी ये जो है नहीं we are lucky to get our papers through. Actually what has happened is, let me tell you the honest truth, this has somehow gotten through the bulk screening process. My papers, they are published in fairly decent. Whatever George Chaldakov and have published, they are small time journals. They publish because they are interested, they know. The major journals that publish my paper, they somehow slip through the things. Yeah. And then there was some editor that supported. some editors supported. They knew. I'm not saying, I told you there are people, good teachers, there are good scientists. But when I say my negative comments come because of large amounts of negative experiences that has accumulated. So there are silver lining in the clouds. I will show you my paper in Biomedical Reviews. Shunning of murburn concept. It's a sham. It's a shame. This thermogenesis paper that we got recently, molecular what is that? MRC, Mitochondrial Research, Medical Research Center, MRC, MBU in UK, where the Nobel laureate is. Their group published the thermogenesis, the uncoupling protein thermogenin structure. So it is exactly as we predicted that arginines and all will be there in the loop, and exactly like that. So we sent a beautiful paper with an alternate interpretation in Science Advances or Science Advances, American Association of Advancement of Science. It was published. 2 months later, it was removed without notification, nothing. You read that paper, you don't know how deep it is. It is very sad, actually. The 2 papers where our letters in Science are published are going not to be seen. The point is like this: there is a machinery, scientific machinery. There are big people. They come from Harvard, Oxford, Stanford, all this, Caltech, MIT, Tim Tum, fancy names, IIT, all that. That's what it is. I'm telling you, that's what it is. The vast number of papers in Nature, Science, all that junk. Big time journals. I'll tell you, don't go by stature, don't go by citation numbers and all that. Go by, if you're interacting with a scientist, see how they interact with you. Are they free with you? Do they appreciate your queries? Are they entertaining your doubts? That's what is the hallmark of a scientist. We have forgotten this real thing in the pursuit of recognition. Only when Nobel Prize comes, we are listening. Only when impact factor comes, we are listening. Nature, Science, each one of my papers is junking hundreds and thousands of all these kinds of Ivy League papers. I wanted major recognition in an early time. Now I want is some people to take all these ideas seriously. It's not about me, it's about you and your forthcoming generations. If you want your people to have cures for diseases, neurodegeneration, diabetes, so many things, you need this. This is everywhere. How can you refuse it? How can you refuse it? It's criminal. It's criminal. It's not. When somebody tells me, that's why I put Carolyn Wells' slide. If you remember, Carolyn Wells said, if something is wrong, everything is known, it should be rejected. That's what scientific advancement is. But then Max Planck, who said that a new truth does not gain rooting in society because of its strength of the theory, was absolutely true. When Richard Feynman, what is his Feynman? Richard Feynman only, no? Feynman, yeah. When he proposed quantum electrodynamics, both Newton, Einstein and Max Planck, the guy who started it all, they opposed him tooth, nail and claw. Such smart people also. But then they did it all with a sense of, purpose. There was genuine nature. Here it is unscrupulous. Because it is very simple, isn't it? What did I say that you could not understand? There is a paradox in what I said, no? I said that you will not understand, and then I am saying what you did not understand. So yeah, is that coffee or tea here? It should be. Yes, it is. Yes, doubts. Yes. 1 second. Oh, it's cookie. It's a cookie. It's biscuit. Okay.
As a physiologist, I'm okay with your concept of conveying about this. But you did everything in vitro.
No. Who told you? Where are you? Where are you sitting? Wait. No. Where? No. You cannot say such things. Here is something. Chloroperoxidase. All
No, sir, I'm talking only with respect to
photosynthesis. I never worked on a plant.
photosynthesis.
I
So,
never.
and a very common perspective that PS2 and PS1 are not 1:1 ratio. PS2 and PS1 are not 1:1 ratio.
Yeah.
They are 3:2 ratio.
Yeah.
And then their arrangement
Different
of
have different.
chloroplast
PS2 and
membrane.
PS1. They are different in different. There are lots of data of different ratios. There's from 1990, 1980s to till now, there have been lots of papers published. Many groups have found many different ratios. Go ahead.
Maybe, sir.
Yes.
So in that, in their ratios, so whatever we just thinking of with respect to that scheme is with respect to from PS2, it is starting and it is moving on through PS1. It is not like that. It is starting with PS2, it is moving on. Somewhere there will be some other arrangements or there. It is, that means from PS1 only NADH is producing. So if it is not moving on to the PS from there, if it is not, so that is what. So
No. You cannot go like that. Tell me what you meant. You said we do not think like this, that it is not going in a serial way.
yes, sir.
Why is it not going in a serial way? Why it is this scheme?
The arrangement is not like PS2, plastoquinone, cytochrome B3, and then plastocyanine.
There is no real physical arrangement like that.
Yes.
Yeah, that is not there.
Then
Their theory requires that. Their theory requires that. Their theory requires that. The theory requires that, but it is not there in the distribution. Okay? I told you PS2 is found in deeper stacks. If PS2 is in deeper stacks, yes. Now, your theory requires plastoquinone to give PS2 to cytochrome B6F. How is it going to give?
No, sir, I'm not conveying like that.
No, you are not conveying. You are nobody as far as this is concerned. This is the authority given in textbooks that is being taught. You cannot say it's my belief that it is not done. This is what is that thing that is taught to our generations and generations for a lot of people. Govindji, you should see in photosynthesis research. He has come to India. He has made master students stand like, I am plastoquinone. Ting, 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 ting. Plastoquinone goes to cytochrome B6F. You have to see that. Yeah, what I'm saying is that is the belief. You cannot say that that is not the belief. The belief is very clear. Belief is a serial electron transport chain. One second, sir. Excuse me, sir. There is one person discussing. We will all be very focused. I'm very particular about this. And what she's saying is very important. When I am saying it is a serial scheme, when the textbook is saying it is no, I'm not saying it is a serial scheme. I'm arguing against the serial scheme. You are saying it is not a serial scheme. Then why am I here? No, it is being said and taught that it is a series scheme. That series scheme is what is Z scheme. That's a Ponzi scheme. No, what a Ponzi scheme. No, basically, am I not?
For UG students, they are conveying, but for as a physiologist, while I'm studying in PhD, we have a separate course for photosynthesis, and we know that there is a photosynthesis, that's a light reaction, it is not a such scheme, and we know the ratios, it is varying for the different plants, that we know very well. So PS2, from PS2, it is moving on. So
what is moving on? What is moving on?
The electrons, the splitting up of the protons, and
then okay. Now here electrons are taken from water. They move on to plastoquinone.
Yes.
Then plastoquinone moves it on to this one, and then it moves it on to plastocyanine. Then it moves it on to this. Wait, let me complete it. It moves it on to this. So what is not serial about this?
No, it is not moving on like this. If their arrangement is like that. If the chloroplast, it is not the same arrangement. This is not the same arrangement.
No, wait 1 second. Let her.
Of the plant.
Yes, that is not. That is what I'm saying.
Yes, this is not the arrangement in the chloroplast of the plant.
Yes.
So over there, their variation is there.
Yes.
And then similarly, the photosystem is having the reaction centers at the center and the light harvesting complex will be surrounding them.
Yes.
And then once if it is observing the pigments, either the light pigment will be converted first as either as a resonance transfer or else as the phosphorescence or else
Oh, nice.
will be there.
Yes.
And then only it will proceed on with their transpiration, the light energy will be converted into the electrons as you are mentioning.
Yes.
Yes.
So, no. So, you have to be very clear what you are arguing for. You have to be very clear what you are. Are you saying this is not a real thing? Then we don't have anything to argue.
This is not the real.
Then we are on one side. I am standing here with you. We are on the same side. Right? Why am I arguing with you if you are saying it's not real? No, even I say it's not real. So, good. Now you are on my side then.
About one important thing, I have a doubt. I thought you will talk about that.
What?
That is about the Rubisco.
Rubisco, I'm not going there. Rubisco, I'm not going there because I have my ideas about it. I'm not going there. It's the most important enzyme that we know. Yes. Let's stick to what we have. The other one also, this nitrogenase, this thing that you said yesterday, very important system. Rubisco is also very important system. We'll deal with it in a later time. Let's focus on what we have here. You agree that this is not real. I have no problem. Don't teach it.
I won't accept this emergence enhancement. Till now, I am not teaching my students about enhancement.
I love you.
I won't do that one because I won't accept those things.
That's all I care. That's good. That's how a teacher should be. That's good. That's good. Yes. A teacher is like that. A teacher doesn't teach what he or she doesn't believe. That's a must. Otherwise, we human beings will not be like this. Yes? This whole structure, this whole thing, this interaction, it won't be. मैं जिस थाली में खाता हूँ उसमें थूकता नहीं हूँ मैं. I do not spit in the plate that I eat. Sometimes if kankad katata, I do that. But then, scientists, when you argue, then you think, oh, that's not a completely correct argument. There are exceptions to the rule. So I have to say it that. That's how I think. So, nice. If you don't buy this, even I don't buy this. You should see the 2 papers Govindji has published in photosynthesis research. 2 papers. This drama and action of series. It cannot imagine one NADPH making that electron from here has to go through 100 transfer process for one NADPH molecule. Why? When Daniel Arnold said that even photosystem 2 can make NADPH, they just threw him out. He showed experimentally. And that's what Murburn says. Electron come out, if they get to meet ferredoxin and NADP, they'll become NADPH. If it goes into other way, it will go into ATP. You cannot just determine what collides with what. You just can't. If it is arranged in a particular close by affinity way, then yes, it will go from here to there. But here, why is it being taught then? The most important thing is that series arrangement to enhance, to explain that Emerson experiment. Emerson was an American scientist. So, Americans want to prop up. That's what I said. Jiski lathi uski bang. 1950, they were Anglo-Americans won the Second World War. They took the world for a ride as far as biological mechanisms are. The Oxford iron pumping physiologist, I put a paper in Progress in Biophysics and Molecular Biology. After 8 months or after 7 months, the response comes, Cambridge physiologists have already established. And then what they did, the Cambridge physiologists, the Murburn Wikipedia page, they, what do you call that? No, yeah, they say, this is not a theory, it has been disproved, nothing. And they quoted some of my own papers for my own disproof. And then after some time they corrected it and put another reference. And then that was not mentioning about Murburn at all. Right? So thankfully, their IP numbers, all that is traced. I copied that, put it in a paper where these people are going. Kill me or you come on track. That's how passionate I am. I don't have any other job. Science is my job. Science is my job. And if you want to take science, I think you should go and have your coffee tea. Please go. Please go. നീ നന്റെയാണ് ഒരുങ്ങി വിരിങ്ങി വന്നില്ലേ? introduce? Hello, can you hear me? With this? Is it coming via this? Okay, good. So, we are coming to the last session of the, tomorrow we won't have an evening session. So, this is the last evening session. This is a short session. I'm not going to go details into physiological aspects of electrophysiology, because I don't think anybody will really be going into the details, because it is once again so simple, pumping and all that. It cannot be possible. I can ask you, what if it is pumped? Well, can it balance? Whether it this geometry, that geometry, it's elementary stuff. So you see this thing now. What Vivian is going to start talking about is the visual transduction cycle, and how a neuron can relay that signal. Now, I would like to say a few words about Vivian first, and I would want to, now once the session goes off, you would want to go home, right? So, and then dinner and all that. Do you want to have a light moment, exchange some pleasantries, share something you want to do? You can do. This is not very hardcore, sort of the, you want to just relax a bit, say something interesting, sing a song or something like that, you want to do, you can do. But keep it sporting, keep it good, and then we will go to the next session. We can have 10-15 minutes or 30 minutes or whatever, good time if you want. If you want, spontaneously, you can. Did you like the proceedings till now? Yes. Say yes. Yes, sir. Yeah. Kya yaar? Korkata vayalilla pole. So, cookies. Korkata illa cookie vayal vechirukar mariya. All right. So, anybody wants to say something, sing something, do something, you can volunteer yourself. Don't volunteer others. Right? Anita madam is a good singer. You want to do it? Danny also sings? Really? Not joking at all. What kind of songs does he sing? Seriously, मजाक तो नहीं कर रहा? Tamil classic. All right. This is not dignified way of interaction. So, if we set some precedence, can we expect some continuum? Okay, I'll go first. All right. You can hear me singing like this also, right? Yeah, I can sing like this. I try to. Okay. पंथी हूँ मैं उस पथ का अंत नहीं जिसका आस मेरी है जिसकी दिशा आधार मेरे मन का पंथी हूँ मैं उस पथ का अंत नहीं जिसका आस मेरी है जिसकी दिशा आधार मेरे मन का जिस पथ पर देखे कितने सुख दुख के मेले फूल चुने कभी खुशियों के फूल चुने कभी खुशियों के कभी कांटों से खेले, जाने कब तक चलना है मुझे इस जीवन के साथ। पंथी हूँ मैं उस पथ का। That's it. My favorite guy. Whose song? Kishore Kumar.
Written, directed, and music by Kishore.
आ चल के तुझे मैं लेके चलूं दूर गगन की छाव में. And that, Panthi में उसका पद था. Was it from that? No. Was it from that only? I think so. Anybody? Danny, want to go? See, I sang for you. I made myself fool like this, that. Make myself likable. Hey, यार दूसरों का मत करो यार, अपने आप को करो. You know that? Have you heard that joke? You say the plane goes. नहीं, plane जाता है. सुनना यार. Plane जा रहा है. ठीक है? So one of its engine dies. All right. So chivalrous, gallant people are filled in the plane. Says so the captain says we'll have to jettison some load. So there are ladies and kids like Titanic. Some guys have to make way. So Vive la France, says the French guy, and jumps. And then the Brit says long live the Queen and jumps. And then this guy says long live Mera Bharat Mahanjan, pushes him out. That's what he is doing. He is trying to make him sing. जब करना तो खुद करना, तो करना, आजा. जिसमें भी यार
गुजराती चलेगा एक दो, फिर बाकी के कान में से खून निकलेगा.
हाँ वही नहीं, तुम इंग्लिश करो.
हिंदी ओके?
हिंदी
English?
English is
Okay, I'll do it in English. Okay, so while I was here,
introduce yourself. Let them know who you are.
Okay, my name is Mohammad Mania. I am a biochemistry student. That is the best thing I've done, and that is the worst thing I've done.
It's always like that. It has got two edges. Yes.
It's very fun, but there are people around you who are also you ask stupid questions. Sometimes you're like, you should know that.
That's good.
So I was reading the paper written by Murli sir. I'm in the train from Valsad to Mumbai. I'm reading it. I'm clutching my hair. I'm pulling my hair. I'm like, ये तो मेरा दुनिया खत्म हो गया. 3 साल की पढ़ाई gone. Like that. Because we studied plants for 3 years. 3 साल ऐसे मोटर पेसल लेके स्पिनच को ऐसा म्यूटिलेट किया. So I'm reading the paper. There's people around me. They're looking at me and they're like, what is this person doing? Has he gone mad? Because I'm laughing, I'm crying. I'm laughing, I'm crying. The things he's written, very funny. But the funny thing is, it's very, shocking. So I'm crying. Oh. I read for 1 hour, 2 hours, and then I'm like, but I can't read anymore. I have no more tears left to cry. Na khushi ke hai, na gam ke hai. So I put it down. I went to Mumbai. I got off. I'm looking around. I go to a hotel. I have my lunch. I'm still reading that paper. Still doing the same thing. इस बार पानी है साथ में, so I have more water. I have tears now. I've refueled myself. Now I'm looking at. I go to the railway station. Then other one. I look at it. My train's delayed. Oh no! I was going to read the rest of the paper in the train. Oh no! I look at the time. It's delayed by 6 hours. Oh no! I won't get there on time. So I'm like, Mama, train is delayed. What do I do?
They book a flight. I told you before, book a flight. No. To train mein jayega. So I booked the flight. Phone. I'm doing it on my phone. For some weird reason, airline booking, phone, you're doing it on your phone. Nah, illegal, wrong. No. My mom is doing it on her phone. No. I pull out my laptop in the middle of a cafe. It's a 500 rupiya diya. I spent 500 rupees to sit in a cafe and pull out my laptop. I try to connect my hotspot. Laptop says no. Password sahi hai. Naam bhi sahi hai. Kyun kar rahe hai? Why are you doing this to me? That day couldn't have gone any worse. Then I'm like, okay, fine. I got a flight for the next day. I said, okay, I'll look for a hotel. I got a room. I paid 500 rupees for the room. The room is yay big. Enough room for a bed. It's this big.
Where, in Mumbai?
In Mumbai, yeah. It's near the airport, so it's good enough for one night. It's not good enough for anything else. I did not mean that. हंसना नहीं था. And I somehow got scammed by the cab. Uber said, you will have to pay 750. I came here, the guy is like, I won't let you go. Why? You have to pay 400 rupees more.
Yeah. That's actually tragedy. Yeah.
I forgot my headphones over there. The guy comes back and he's like, you have to pay 300 more to get your headphones. Like, le bhai ja. Okay, that was my time. Thank you.
Coming here was that.
Yeah, coming here was hectic. Hopefully not as hectic.
Yeah, I hope he doesn't have this time when he goes. Yeah, nice. So you're doing a biochemistry master's or undergrad?
Master.
Where? Oh, Charu side. Tera hai.
We got some details about it.
Oh, okay.
No, the paper came in an email.
Oh, that AIB advances paper.
Yes, the AIB advances.
25 years ago. Yeah. Okay. Did anybody else read the paper? It has come to all of you.
Usually, most of them have got some videos or anything while they are coming.
I was reading the paper and then I'm like, okay, I'm bored. I'll watch some YouTube. Like, okay, now I'm bored of YouTube. Now I'll read.
Now, actually, you know what? If you find the right fix for your life, nothing like it.
Yeah, because I found the paper very interesting, so I'm like,
Yeah.
I'll read it.
Nice. That's good.
Now we can think. Now we can see.
गाले यार ध्यान पढ़ all right please.
சொல்லாத காதல் எல்லாம் கொல்லறையில சேரும், நீ விட்டு போன தூரம் எல்லாம் தீயாகும், என் இதய செல்லில் கூட அன்பே உந்தன் பேதானோ, 1000 ஜென்மம் தீர காதல் நீதானோ, உன் மூச்சு காற்றினை நான் தொழுதிடவா, என் காதல் யாவையும் வாடகை விடவா, காதலின் நாள் கடல் நான் அறிவேனே, உன்னோடு காதல் செய்ய கதைத்து நிற்பேனே, நான் உன்னை சேர்க்கையிலே உயிரே உனதாய் நான் பிறக்கவா, நான் பிழைக்கிறேன் ஏனோ உன் விழிகளில் தானோ, நான் பிழைக்கிறேன் ஏனோ உன் விழிகளில் தானோ பள்ளிவாழ வற்ற வஜகம் ಕೈಲೇಂದೂಂ ತಂಬೂರಟೆ ನಲ್ಲಚ್ಚನ ತಿರುಮುಖ ಚಂಡು ಕಲಿ ತೊಡಂಗಿ ತೀರಾಲ ವಾಗನ ವೇದಿ പോകുന്നോ തമ്പൂരട്ടെ നല്ലച്ഛന തിരുമുഖ ചണ്ടുകാലി കളി തുടങ്ങി അങ്ങനെ തേകി വേഗി തേകി വേഗി തേകി വേഗി കാകാനിട്ടു ஏண்டி உன்னனா லவ் பண்ணன ஏண்டி உன் பின்ன நாயா சொக்குறேன் ஏண்டி உன்னனா நாளோ நினைக்கிறேன் அடியாண்டி அடியாண்டி அடிய உன்ன போல பொண்ணு இந்த உலகத்துல பார்த்ததில்ல எந்த மனச கொள்ளை கொண்ட பொண்ணு வேற யாரும் இல்ல அழகே அழகே என்ன அழகே நிலவே நிலவே முழு நிலவே அழகே அழகே என்ன அழகே நிலவே நிலவே முழு நிலவே.
Thank you. Prasad, I told you this guy was a drama buzz. You should have seen this guy. The first day he comes, Pakka, what a scene. Hey, Muthu, இவன் தாண்டா அந்த ஆள் தான்ல, this guy, sir, இல்ல உன் பின்னாடி வர்றதெல்லாம் யாராச்சும் வந்திருக்காளா இங்க? Okay. No, he sang saying that, why am I chasing you? Why am I coming behind you? All right. So he said that after the registration got over, these guys convinced me to allow this guy in. I knew this guy was a fraud. And then he said, sir, I want to go. Okay, partner Marida, he was doing that. So then what I said, okay, these guys all convinced me to make an exception out of him. And then day for yesterday, he is there in the Saindram. Just I went there. This guy is standing there. Sir, there is nobody there, sir. This guy, our professor, he was trying to make him talk. Hey, you should ask. And I said, you don't know this guy. He's a bloody big fraud. What? Isn't it true? He is not breaking out of a cocoon metamorphosis. He is not a caterpillar getting into a butterfly. He was a Paji. Earlier he was a Paji, now also. Good, I like that. You have to be bold. You have to be confident. Yeah, that's what it is. Anybody else wants to use this opportunity? Well done. Dayanidhi. Come. Hey, come.
I just forgot this name. I'll just fight. चुरा लिया है तुमने जो दिल को, नजर नहीं चुराना सनम, बदल के मेरी तुम जिंदगानी, कहीं बदल ना जाना सनम, हो ले लिया दिल, ओ है मेरा दिल, हाय दिल ले गर मुझको ना पहलाना, चुरा लिया है तुमने जो दिल को, नजर नहीं चुराना सनम, बदल के मेरी तुम जिंदगानी, कहीं बदल ना जाना सनम.
Wonderful. Thank you. Our dean is here, Professor Soman, and Sai Sundar, he's our Chief Innovations Officer. So, yeah, you know, just to introduce. Yes, so tomorrow at this time we'll be separating. So we have only 2 sessions and maybe 1 quiz interaction, and then your discussion, and that's it. So we have some time. So that's what we just started, a few minutes of some interactions. Anybody, anything else? Yeah? No? That's it? But we are sports. So two faculty and 2 students, right? Good. Good. So that's good. So is that it? Anybody wants? Anybody wants to come forward and do something? You see, this is the way you can lose a little bit of inhibitions, and this is the way you can gather some confidence. You can just say certain things, what you learned. You can use it for any kind of projection, communication. Any kind of communication. It's not singing, not comedy, anything you can do. It's a free for all now. You can grab the mic and say anything you want. അവിടെ പോയി പറയാൻ വയ്യ ഇവിടെ വന്നാ എന്ത് കുട്ടി പറ്റും അതെ ശരി അടിപൊളി അടിപൊളി ഹലോ യാ these kids are from St. Joseph's School, St. Joseph's College, where I had gone once to give a talk, and they are my students. Introduce yourself.
My name is Nija. I'm coming from St. Joseph College, Herein. Okay.
What are you studying now? That's what our sir is asking.
Integrated Programming Biology. We are combined MSc. I mean both.
Yes.
Integrated course ana.
5 years ana, 4 years ana?
5 years course.
Which year are you now?
3rd year.
Okay.
கண்மணி அன்போடு காதலன் நான் எழுதும் கடிதமே பொன்மணி உன் வீட்டில் சௌக்கியமா நான் இங்கு சௌக்கியமே உன்னை எண்ணி பார்க்கையில் கவிதை கொட்டுது அது எழுத நினைக்கையில் வார்த்தை முட்டுது ஓ கண்மணி அன்போடு காதலன் நான் எழுதும் கடிதமே பொன்மணி உன் வீட்டில் சௌக்கியமா நான் இங்கு சௌக்கியமே
Nice. That's a sport. That's good. Now, hopefully, you get these guts to ask questions too. ഇതേ ധൈര്യമില്ലേ സാറേ ചോദ്യം ചോദിക്കാൻ ഇവര് കാണിക്കും. Yeah, anybody else? Dance? And who said somebody dance or something? If you want, you can do. We have some time and then we'll start with the presentation. Once it becomes serious, then we cannot go back. You understand? All right. Can we? No. That's good. That is Guna, illa? Guna, Kamalasan. Huh? Your gang? What is that? What is it? Oh, Baisonal adu Gunana. Original, always precedence. Recycled is recycled. Huh? There. Yes. Yes. Ah, we have another teacher. We got wonderful. Please introduce yourself. Bhuvaneshwari madam from, sorry, please introduce yourself. Bhuvaneshwari madam.
Good evening, dear friends and students. I am Dr. Bhuvaneshwari from Trichy Bishop Weber College, and I'm an assistant professor in zoology department. Some sang the song and some shared some jokes. But I'm going to do something different. But I hope you never expect this from a girl or a lady.
Okay.
Any guess?
I haven't.
Like you said. Let me ask some questions.
Yes, sure.
Any guess?
Mimicry.
That's correct. So I hope learned colleagues are occupying the front row. I would.
Yes, please go ahead.
I'd like to ask a question. If any student has deviated from your class,